From molecular biology to astrophysics, it's clear that digital animation plays a huge role in both science communication and science exploration. Today's tools make this easier than ever before. There are free tools like Blender and Maya that can produce high-quality animations of any kind. These tools, though, however, are limited by their steep learning curves, hours-long rendering times, and inability to change the behavior of an animation using real-time data. Enter Three.JS. Three.js is a JavaScript framework built for quick, easy 3D animation. And yet, it's got a lot of power. All the animations you see right now were built using Three.js. In the past couple of weeks, I've built a simple animation of two Earth-orbiting spacecraft using Three.js. Check it out. Here's a view of the sun gloriously rising from the spacecraft's perspective. Here's an Earth-centered view of both spacecraft, one held static for now. The animation is fast, web-based, driven by easy-to-change constants, and quick to make. I want to walk through some of the Three.js concepts needed to build this animation. Everything is built on a canvas called a scene. All objects are represented by meshes, which include both the geometry of an object as well as its outer materials and its response to lighting. For example, I textured the Earth by starting with a sphere, adding an image map to its surface that I found online, and adding lighting from the sun. The sphere geometry and the reflective mesh material are all presets provided by Three.js. The spacecrafts were even simpler, modeling them as a colored box with some arrows indicating key vector directions. From here, adding animation was as simple as specifying a circular orbit as a time-based function in code and stepping through a loop that incremented time. Finally, embedding controls for the animation was as simple as adding HTML buttons on a web page. I implemented a way to change camera views, which will prove extremely useful for the upcoming real spacecraft mission that this animation will be used for. And there we have it. This visualization only takes a few hundred lines of code and demonstrates that creating animations really is within the reach of anyone who wants to try it out. What will you make?